Okay, so we're going to get started with exercise 217 today, and I think this is kind of a fun one because we're actually going to go through the process of how do we make the physical model of our little skyscraper that we've spent a lot of time designing and playing around with. And so I'm going to walk through kind of the two methods, one of which is, of course, 3D printing. We'll talk about prepping the 3D print file. And the other one is if we wanted to unroll the surfaces, kind of like you did in 130 when you made the little cubes and the triangles where you folded things flat and then you folded them back together. We can do the same thing in Rhino using a command called Unroll Surface. So we're going to do two things. We're going to start by unrolling the surfaces, and then we're going to make the 3D print file and actually generate the G-code. Both of these are required parts of your assignment 203 that you're going to be working on. So it's probably not the same building that you'll do today, but you'll end up doing the same steps for your assignment 203. So we're going to go ahead and get started. I will reference a couple things today. I have obviously the handout that's in front of you is online here, and we'll go through. There's some links to tutorials. There's also some text here in the second part about the Watertight model that I will reference. There is also a tutorial that's on the website. It's Physical Modeling 6.5. This is 3D printing from Rhino that will walk through a lot of the actual generating the G-code settings and whatever. There's you can see there's a lot of images associated with this one. I will have to reference this file that has all the correct settings. So it's normal for you to have to look it up and reference it. I don't have all of those memorized. And then I actually wanted to point out that I do have a tutorial that walks through how you can actually do the 3D print over in the computer lab. This is for the Type A machine, not the Delta maker. We're working on the Delta maker to get that work, thanks to Will Fry for setting that up. But anyway, what we're doing today will be related to the Type A machine. So those are all there. I will come back and I will reference those as we're going through the steps. But we're going to start by opening up Rhino and then opening up the skyscraper file that we created in exercise 214, I think. The one that we brought in to do the background renderings into the San Francisco city model. So I'm going to go ahead and go to open here. I'm going to go onto my flash drive. And in my folder right here, the exercise 214, that was my skyscraper. I'll go ahead and open that one up. And there it is. And I want to make sure that I do a save as because I'm going to start destroying this file. So I'm going to go to File and then Save As. And I'll actually drop it into my folder for today at 217 here. And there, we'll just go ahead and overwrite that file. And there it is. So I've essentially taken it, made it its own file. Now I can start editing it and working on it. So if you remember from last class when we were setting this up, we had our skyscraper primary layer. We had our floor, our skin, our ceilings, and our core. When we're working on the unrolled surface, we don't care too much about the floors and the ceilings and the core because those are all kind of superfluous to the shape of the building to begin with. So most of that I can turn off. There is an optional part with the floors that I'll show you about in a little bit. But I can essentially turn off the ceilings for sure. They can go away. I can turn off the building core. And I'm going to switch out of the rendered preview into the shaded preview so we can see the building on the outside there. And really, the skin, this part, is the part that I care the most about. So for right now, looks like I'm confirming a couple things. I have a top to this shape, and the bottom might actually be on a different layer. Yeah, it's on the floor layer. So I'm going to take the bottom of this and put it on the skin layer for clarity. So I'll right-click on the skin layer and say Change Object Layer, and it's now on the skin layer. Obviously, that part of my building is on the skin layer as well. Let's turn off the floors. So I'll make the skin layer active so I can turn off the floors. And now all I have is the skin. I do have a top and I do have a bottom. And for our purposes, the core, the little pop-up of that elevator shaft at the top, I'm not going to worry about that and unrolling it. You could do it if you wanted to, but it's not relevant for the big picture. So I have this whole skin. I'm going to select all of it. So I held down Shift there to select all of it. And I'm going to go ahead and join that whole thing together. So I can go up to the Edit menu and choose Join. I could press Control J, or I could type in Join on the command line. Any one of those is fine. And it's going to join these individual surfaces into one polysurface. It's important when we do the unrolls to join it into a polysurface because edges are going to match up. If we unroll, we could unroll each surface individually, but you'd have to manually figure out which surface matches with which surface. And that's a lot harder than making it a polysurface first. So it's a closed polysurface, and it's now time to start the unroll command and basically flatten out the pieces. And remember that this has to be done with what are called ruled surfaces or lofted surfaces, because at any point along the side, there is always a straight line. So if I looked at this twisting surface here, there's a straight line from here to here. If I moved up this edge and I went across, there's still a straight line there. It's not bulging out in 3 dimensions. So what we don't want is curvature in 2 directions. And if you have that, Rhino's going to throw an error saying, I can't unroll this because it's not a developable surface. And so for some of your skyscrapers, you'll run into that problem. And if that's the case, we'll go through and I'll sit with you and we'll simplify it and take that bulge out, and you'll still be able to unroll it. So in my case, this is a developable surface, so I can do the unrolled surface command. And to do that, I'm going to go ahead and create a new layer to put these unrolled pieces on. And so I'll click on the New Layer button over in my layer palette here. And I'll call this Unrolled. Let me pull it out of the skyscraper layer stack, and I'll also make it the current layer. So that unrolled layer is current because when I create these surfaces, I want them to go onto that layer. And so it's pretty easy to initiate the unroll surface command. You can type in unroll srf, or you can go to, sorry, there it is. It's under surface and then unroll developable surface. So I always type in unroll srf. So that's unroll srf. And it says select surface or polysurface to unroll. Well, that's easy. We can select that. But then there's a series of options that come up on our command line here. We have explode set to yes or no. Generally speaking, you're going to want explode set to yes, which is going to break apart all the individual pieces, because it's rare when your building is so simple that it can stay joined together and unroll correctly. So generally speaking, explode is going to be set to yes. Labels should be also set to yes. So I want to click on labels or type L for labels and make sure that that's turned on to yes. If you keep it as no, when you go to unroll the surface, you're going to have trouble figuring out what matches up with what piece. And so it's always good to have some labels for reference. So I'm going to have explode set to yes, labels set to yes, keep properties set to no. That means it's going to go on my new layer, not its existing layer. And I'll go ahead and press enter. And when I do that, it's going to take all of the pieces from my building and break them apart into their unrolled surfaces. And so you can see them all laid out flat there. But we can also see the reference on my tower of which pieces match up with which pieces. So for example, this edge 16 should have one on the top here and one on this back side. And when I come over here and look down at it, see if I can find 16. There's 16. That's one edge, and that should match up with an edge that is 16 somewhere, if I can find it. There it is, 16. So this edge here should match up with that edge right there. So we need to do some general reorganization of this so that we can see it. So I'm going to go ahead and select everything that's on the unrolled layer. I'll right-click on Unrolled and say Select Objects, so I can select everything. I'm going to hold down the Control key and deselect the labels on my tower so that they don't move. And then I'll go ahead and move all of those surfaces just to get them out of the way. And I think for me it's always easier to look at this in the top view as you start to lay this out. And then it's a matter of reassembling all of your pieces. So let's pull this one over a little bit. And we'll start with this one. This was the top edge with 16. We already found piece 16. I'm then going to move this piece. Oh, I don't have my snaps on. Let me turn my object snaps on. End, mid, and perpendicular are my standards. And we'll go ahead and move this and line up edge 16 with edge 16 right there. If I rotate this, and I'm typing in rotate I could alternatively go up to transform and then rotate. If I rotate this surface right there to right there, the length of 16 should match up perfectly along that edge. That's a sign that I'm doing it correctly. As I continue on here, there's more pieces. 9 should match up with 9. So let's go ahead and move 9 to there and then rotate around to right there. And again, that should match up perfectly as well. 12 should match up with 12. We can move 12 over here. And we can rotate this like that. And again, that should snap nicely. 10 here should match up with 10 right there. And we'll go ahead and rotate again to right there. There are cases where this piece would intersect with one of the other pieces, where it folds back on itself. That's problematic, because obviously you can't cut out two pieces at once. So we need to make sure that they don't intersect. It looks like piece 13 needs to move. So we'll go ahead and move that there and then rotate it up into that position. That's my bottom. We'll come to that in a little bit. Move that over there. So I'm working my way through this. Now piece 11 theoretically matches up with piece 11 here, but that would intersect with this piece. So that's not a good place to put it just yet. So we'll just leave it over here to the side. I'll come to that one in a second. As we continue our way down, we have some more pieces to line up. So here's 15. Let's move piece 15 here, and then rotate piece 15 like that. So there's 15. Let's see, there's 18. Oops. So one of the keys is I'm never actually flipping anything over. I'm always just rotating. So we have to make sure there's no mirrors. It's just rotations. There's 17. Like that. So piece 11 and piece 24 do go together. So I can put them together as I'm starting to organize, but they still don't quite have a home just yet. We'll get to them in a little bit. Let me move them over here. All right, what else do we have? There's 21. Go there, rotate. And 19 would be right here. Rotate like that. So I still have this piece over here that's floating, but I also have a bottom right here that hasn't been aligned just yet. I still need the bottom to kind of line up. And the good news here is I can use the bottom, this piece, and I can use piece 3 together. So let me move these guys. And we'll rotate again so that those two correspond. And I can take these 3 and I can line them up either with edge 0, with edge 28, with edge 1, or with edge 4. I have a choice. I'm going to do it with edge 4. And I'll go there and I'll rotate one more time to right there. And again, my pieces didn't ever intersect, so that's a good sign. So essentially what I'm looking at here is the pieces necessary if I was going to cut this out, glue it together, and fold it using a piece of paper to make my exact model. And it does, believe it or not, work. I could go laser cut this. So in order to laser cut it, we have to actually create the laser cut file. And this is part of your assignment 203. So we're going to go through the process. This is not good enough because we can't laser cut this just yet. We have to prepare it to do the laser cut. So I'm going to create 2 layers. I'm going to do a master layer called laser cut, and then I'll create a sublayer for cut and another sublayer for engrave. And this should look somewhat familiar to the topography. We did the same thing here. The cut layer is going to be set as red, and the engrave layer is going to be set as blue. So I'll go ahead and I'll make the engrave layer active for right now. And I need curves that go around all of the objects. And I have two different options as I create those. I can use the dupe edge command and just walk my way around the edges, which to me I think is the right strategy. The other option would be to use the duplicate border. But in that scenario, you'd end up with a line that goes across here, which you really don't need. So it's a little bit redundant. So I'm going to work my way around my objects. I am concentrating on all of the fold lines. So that would be a fold line. I would fold it right there. I would fold it right there. OK, so I've worked my way around all of those. When I hit Enter, it's going to create a bunch of blue lines for me. And I can actually, at this point, turn off my unrolled surfaces altogether, and we'd see the starting of this laser cut file. Now, if I were actually gluing it together, if you think for a second about this edge would need to glue and attach to this edge, I'm going to need some little tabs or something to fold to glue to, because otherwise I have two edges. I mean, I guess theoretically you could cut it out of like a 2-ply museum board and try to glue the edge together, but it's a lot easier to cut it out of a Bristol and just fold the tab and glue the tab. And so in this scenario, I'm going to offset these curves over a little bit to create those tabs. So I'll use the offset command, and I know that these ones are ultimately going to be cuts, so I'll go ahead and switch to my cut layer as my active layer. I'll do an offset, and the offset distance is just kind of an arbitrary value. We need to specify what it should be. I'll say that the distance is probably about like that for my tab. It doesn't really matter what the actual value is. Looks like I'm at about 60 feet or so. And we'll go ahead and say, or 60 inches, sorry. There's a tab. I'll repeat, there's another one. We need one off the top here. We need one there. We need one there. But this edge, we don't need a tab because we already have a tab there. We also don't need a tab along this edge because we already have one. We'll need one here. On this, we could have one there, but we then wouldn't need one here. We'll put one at the end. We'll go ahead and put one there and there, but we won't need one there. We don't need one here because it corresponds to right there. We don't need one on this edge because it corresponds to right there. This matches up with that edge, so we don't need one there. This, I'm not going to put the tab here. I'm going to put the tab there instead, because it's a better spot to put it. So no tabs coming around. We get to this edge here, and I have a choice. It could be on this, or it could be on this. It's either one. So I'll go ahead, and put it right here. And we'll put one at the end there. And we need another tab. And we can do it right there and right there. And that should be all of the tabs we need. So I've worked my way around matching up the sides visually in my head. I need a few more lines to kind of finish cutting all of these out, otherwise it wouldn't cut out completely. So I'll go back into my tools. I'll use my basic polyline tool. And I'm just going to draw little lines there. The halfway point, there was a slight gap. I could choose to draw a little line there. Truth is, it probably would cut it out just fine. There it is right there, without having to split it. Kind of doesn't matter. Down here, we'll draw that. This one goes over, so I need to do a trim there. So we'll do a trim. Oops. Hold on a second. Doesn't like me today, apparently. There we go. So I've trimmed that off. Now, this line here is going to end up being a cut line because it doesn't have a tab, so I need to cut it out along there. So we'll actually take those two lines and we'll convert them over to the cut. So we'll change object layer. They're now on the cut layer. We'll draw a little cut for that end of the tab and for there. These two need to be moved over onto that cut layer. So I'll right click and say change object layer. That needs to go there. This needs to be cut out, so we'll right click and say change object layer, and that's cut out. This is ultimately going to be a cut, so we'll right click and say change object layer. I need to do a little trim there. Oops. There we go. That would be a cut. I'm basically walking my way around my drawing, making sure that it's going to be ready to go cut it out. That's good. Same thing there and there. I need to do a trim on that edge. So we'll take this and we'll trim it for that. But this and this and this and this and that all need to be cuts. So we'll right click and say change object layer. That cuts out there. This would be a cut, change object layer. A couple more. Trim. It is important to do those trims because you don't want part of your actual building to have a cut in it. So we'll make sure that we are making those corrections. And that should be the last one, change object layer. So this is ultimately what I need if I were going to go walk over to the laser cutter to be able to cut this particular building out and glue it together. And I have an example in my office I can go get a little bit later of one of these little things that was cut out on the laser cutter and glued back together. So this would, if we folded it, and if you're really careful about how you align it, it will actually twist and bulge the way it's supposed to. This would be one way of building out a prototype of your building. It's a quick prototype. So you can test the form, see what it looks like, see if it feels right in an overall context. So for your purposes today, I need to see this file with the red and the blue lines. I'm looking specifically for that. You can do a capture of this when you post it. So we'll click the little triangle here, go to capture to file, and we'll take a capture of that. You'll save it. That's one piece of what you're posting. If we were actually going to laser cut this, this would be the opportunity where I would take the overall piece right here. I probably should move it to 0, 0, and I should probably adjust the scale, put it on a bed like we did for the topography, and then I would take this and export it to AutoCAD. So I'd go to File, Export Selected, and I'd come down here to AutoCAD Drawing, and this would be the 2004 polylines, and I'd say OK. That would then be my file to go laser cut. It's not necessary for today, nor is it necessary for the assignment to actually do the laser cut. I'm not going to have you guys make that. I just want you to be prepared so that you can do this in the future. You know, for those of you in the skyscraper studio, that would be an ideal scenario where you could test out your kind of form and see what it looks like in a relatively easy way. So that's one thing that we're doing. That was part 1 of exercise 217. Part 2 of this is to create the watertight model that we could then go and perform the little 3D print of. This was the example one that I did last semester with it. So we're going to go through that same process here. I'm going to go back. I'll save this. Let me do a file save as, and we'll call this the 2019 Unroll. And I'll go back to the original skyscraper right there. And we'll look at this as kind of a fresh start to the watertight model. And so on this particular option, we care about some different things. So we, again, don't care about the floors and we don't care about the ceilings because in this case, the floors and the ceilings aren't really relevant to our 3D print. We're not going to print all of those individual little floors. So let me switch this into shaded mode so we can see it. There it is again. But I do care about the little tower. I want that little piece to pop up because it's an easy part to 3D print. So the other part of this is I don't have, I turned off the floor. That's my bottom. I need that bottom. So I'll come back with the floor. There it is. And I'll change that to the skin layer. Like that. Then I'll turn the rest of the floor layers off. The ceilings are already off. Looks pretty good. So again, I'm only concerned with the outer surface of the 3D print. What happens inside of the 3D print is something that the 3D printer just fills in. It creates a light structure inside that supports the outside, but doesn't use 100% solid filament. So that would be wasteful of the filament. So we create essentially a shell, and the inside is kind of a hollow strut thing. Actually, there's a good set of examples that Will's working on over there about the different infill patterns that happen on the 3D printer. So anyway, when we're doing this, we need to create what's called a watertight object for the 3D printer to be able to actually print. And so the only way we can determine if this is a watertight object, and by watertight object I mean that every surface joins together to form the overall shell that we're trying to print. The only way to test for that is to use a command called show edges. And it's written down here on your handout, but I'm going to go ahead and type in show edges like that. It's going to ask me to select surfaces, polysurfaces, and meshes for display. I'm going to go ahead and type all so that I have everything displaying here. And I'll go ahead and press enter one more time. That brings up this edge analysis window. We don't care about all edges. What we want to see are what are called naked edges. These are edges that are not joined to anything else. So when I have naked edges clicked here, we can see that, okay, the middle part of my skin, which was a joined polysurface, doesn't have any naked edges. This surface here is joined to that surface there without a problem. If I were to explode this, we'd see that every one of those is a naked edge. So it's not a naked edge. That's a good thing. I just undid it. But you see we have problems here, and we have problems down here. So because this is set for naked edges, this is how we're going to solve the problems. So I'll go ahead and say, okay, well, let's take this, and I'll hold down Shift and my skin, and let's join those two together. Okay, well, that got rid of the naked edge that goes around the outside. This surface has a hole that's cut in it for the core, but I have the end of the core right here. So I could take this and the last piece here and join those together. It solved part of the naked edge, but there's also a naked edge from, let me switch this into ghosted, the core that goes all the way down. Likewise, up here at the top, for example, I have naked edges all over the place. So I could take these like that, and I could join them together. I'll go ahead and type join. And that got rid of the upper naked edges, but I still have this naked edge right here. So what I need to do is I need to take this top floor and go ahead and trim out what's happening on the inside. So I'll type trim, and I'm going to get rid of that core. And see how when I'm looking up at it, it's kind of hollow when it comes up? Remember, we're creating a shell. I'll press enter. I still have the naked edge, but I can take this and the top, and I can join them together. And of course, it didn't work. And when I join those two together, assuming I type join correctly, that naked edge there goes away. Likewise, down here at the bottom, the naked edge has gone away because I've joined those pieces together. So I now have a completely enclosed shell. I have nothing inside of it, and I have completely solid, no naked edges object. And so that's really important when it comes to creating this 3D model. So that's the first step, no naked edges. We got rid of that. We can go ahead and close the edge analysis tool. That's fine. And I can switch it back from being in shaded mode to being in our regular solid mode. Now the next piece of the puzzle is that unfortunately the 3D printers don't recognize NURB surfaces. They want a polygonal mesh. So we need to actually convert this object into a mesh. And the good news is Rhino can do that relatively easily. The command to do that is just called mesh. Hold on, I'm double checking. It looks like I scaled it first. I could scale it after. It doesn't really matter the order. I'm going to go back and scale it right now. But again, we can do it in either sense. So the size of the laser cutter or the 3D printer bed depends on which 3D printer you're using. The Type A machines, which is the one that I'm talking through today, has a 12-inch by 12-inch by 12-inch bed. So we could theoretically print an object that's 12 inches by 12 inches by 12 inches. If you did that, it would take forever. So we're going to try to shrink it down a little bit more. I'm suggesting, based on the size of your skyscrapers and the number of floors, etc., that we're going to do it at 100 feet equals 3/4 of an inch, or 3/4 of an inch equals 100 feet. And that would mean that if you have the 808-foot skyscraper, which is your assignment skyscraper, if you're doing that one, it would be 6.06 inches tall. And if you have the 600-foot tall skyscraper, which is the one we did as the exercise, which is what mine is, it would be 4.5 inches tall when we do the scaling. So I've given you those two. You could calculate it out yourself if you had a different size. I'm going to go ahead and scale that down. I'll take my closed poly surface here. I'm going to use the regular scale. So it's under transform, scale. It's a scale 3D, because we're scaling in all directions at once. Or you could just type scale. And I'm going to snap to this corner here and right up to that corner there. So that's my overall height. And I want to shrink that whole building down. So my new height is going to be, where is it? 4.5 inches. And it disappeared. No surprise. That's got really small. It's just like when we did the topo lines, when we scaled those down. So let me press Z, enter, S for selected, enter, and there it's going to be. These lines here are my cage. That was from a long time ago. Those could get deleted. At this point, I don't need them anymore. I could actually take this object if I wanted to clean it up and get rid of all the excess stuff. I could export this object altogether into a new file, which might be a good strategy. Let me go ahead and do that. I'll go to File and then Export Selected. Let's put it into today's folder. And it's still in a Rhino file. Let me go ahead and open that one up. And that just got rid of all my excess layers. So it cleaned it up a little bit. OK, so now I need to convert this from this nice smooth NURB surface into a mesh, because that's what the 3D printer is looking for when it goes to print. So to do that, all I have to do is type in the mesh command and press enter. And it's going to ask me to select surfaces or polysurfaces. We're going to select the polysurfaces. There it is. That's my nice closed surface. I'll press enter, and I get this polygon mesh options slider. And it doesn't mean much unless you hit the preview button, in which case you can see a preview of how it's slicing up your building. Now recognize that this is making some facets, some triangular facets out of the curving smooth surfaces. So you can see on the front here that it's kind of simplifying the curve that I have, that inverted curve. If I drag this over and hit preview again, you'll see that it's making smaller sections out of it. And you can actually see it on this. I can pass this around again. A lot of you have seen this already. You can see the facets or the triangles on the surface. It's not as smooth as it otherwise would be. So I can go ahead, and the higher I make this, the fewer or the more little facets they're going to be. Once I have it set, I'll go ahead and say OK. I now have two distinct objects. I have my NURB surface right there, and I have my mesh next to it. Let me move them apart so you can see the two of them. So there's my original right here with the smooth, and here's my faceted little mesh, my triangulated mesh, which doesn't look too bad. It looks pretty close. This is the one that I can 3D print. This is not the one that I can 3D print. So we're almost there. I have this scaled down to its correct size at 4.5 inches. I could actually go ahead and delete the NURB surface because it's not relevant anymore. The last part of this is that inches is not a unit that the 3D printers play with. They play with millimeters. So I need to convert my units over into millimeters. So I'm going to go ahead and type in units. And I'm going to switch my model units right here into millimeters, which is what the 3D printer is looking for. I'll go ahead and say OK when I do that. And this comes up. Do you want to change? You're changing from inch to millimeter. Do you want to scale the model? You need to say yes here. Yes, go ahead and scale. I'm going to zoom E for extent so I can see the whole building again. Now my units are in millimeters, and this is actually ready to take over into our slicer. So I'll take my object one more time. I'm going to move it. I need to turn on vertex snap so that I can snap to the actual corner. Make sure it's at 0, 0, 0. Let me zoom selected just so that it's at the origin. It's easy when it comes in, all nice and clean. OK, I'll leave this one selected, and I need to do an export here. So I'll go to File, and then Export Selected. And we're not going to be in Rhino anymore. We're going to choose a file called an STL, a stereolithography file. And so if I can find it, there it is, an STL file. And we're going to save this right there. And I'll go ahead and click on the Save button. The options here, the defaults are just fine. You'll go ahead and just say OK. And it's now written the STL file. So that STL file is the first piece of what I need to do the 3D printing. So I went through all of those steps to prep my file for 3D printing. It's ready now. I have the STL. Now I need to actually generate what's called gcode. And that's the code that tells the 3D printer, move from here to there and extrude along that line. And then move from here to there and extrude some more plastic. And then move from here to here and extrude some more plastic. That's how it builds it up, layer by layer. So we need to do that, and we're going to do that in a software called Cura, which is available on all these computers. It's also available in the computer lab. At this point, we need to be specific for, are we going to work on the Type A machine, or are we going to work on the Delta Maker machine? We have two different styles of machine, and the settings are different. The Delta Makers are just now starting to be used. They weren't used for 4 years or so. So I don't have the write-up on that, so we're going to proceed with the Type A machine for now. But I'll have a write-up so that you guys can see what it would be like to do it for the other version. So Cura is on your desktop. It's this blue icon with a C on it. It's made by a company called Utilimaker, who also makes 3D printers. To open it, if you double-click on it, it won't open. We love these computers, right? So right-click on it and say Run as Administrator. Say yes. Good news is there's no password required. And this will actually open. OK, so this is Cura. It's currently set up for the Utilimaker, which is, again, the company who makes this piece of software, their 3D printer. We need to make sure it's set up for our 3D printer, which is a Type A machine. This, by the way, I will come back. I've gone through a lot of the tutorials and stuff that I've talked about, but I'm going to come back and reference what we're doing here. So if you get a little bit lost in these settings, just remember to come back and look at this physical modeling 6.5 because there's lots of little details in it. And so if you follow it step by step, frequently it's a little bit easier. So first thing I need to do is load up that Type A machine's 3D printer, which is the one that we have over across the way. And I'll do that by going into my preferences, and then I'll choose Configure Cura. And on the left side here, we're concerned with printers, and I need to add a new printer. So I'm going to click on Add. It's not one of their printers. It's under Other. It's called a Type A machine right there, Series 1 2014. That's the one that we want. And once I have that, I'm going to click on the Add Printer button. And it will load in the Type A machines, at which point I can go ahead and say Close. And it's subtle, but the background imagery changes just a little bit. The bed looks a little bit different. And so this is now what I can work with. This is the 12 by 12 by 12 piece that I can then insert my model. So at this point, I have my STL file. It's time to bring that into Cura. So I'll go to File and then Open Files, and I'll go find that STL file that I just created. So we'll go into our folder for today. And it was this one. And I'll go ahead and say Open. Now, assuming that I created my STL file and it has no naked edges, it's a nice closed thing, that I scaled it down correctly, that I converted it into a mesh, all of that, assuming I did all of that, it will come in and look gold like this. That's a good sign. If something went wrong and it's too big, it won't come in, and you need to go back and rework. Something went wrong in your Rhino file. It's probably, most likely, it's the scale part. That's usually what goes wrong. So this is now 4.5 inches tall, and I can actually click and drag and move it somewhere on this bed. It doesn't matter where it prints. This is the whole bed. Now, if every single print is done right in the center, it's going to wear out the very center of the build plate. So it's good practice to kind of nudge it around a little bit. Again, it doesn't matter where on the plate it's moved. It just kind of helps even out the wear just a little bit. I wouldn't put it way out on one of the corners, but just be reasonable about where it goes. It doesn't matter for the sake of the actual 3D printing. So now my object is in Cura, and it's time to go ahead and start setting up some of the settings for the 3D printer itself. So last semester, boy, it's raining. Last semester, I spent some time thinking through and testing out what the best options were for time of 3D printing versus quality of 3D printing, and trying to decide what's good to sacrifice and what's good to speed up the time. 3D printing can take a while, so these settings do start to matter. So I have pulled up here that tutorial, and I have all of the settings written out right here, so I can go back and reference these settings when I'm setting it up. Some of these I have memorized, some of them I'm going to have to come back and reference as we go through. So over here, I'm not going to go with the recommended. I'm going to jump over into the custom settings. And when I'm in the custom settings, I'm going to start first with quality. And my layer height should be at 0.2 millimeters. That seems to work fairly nicely. I'll move to the shell. And so the shell here, I'm going to increase the wall thickness from 1 millimeter to 1.5. And I've found in my test prints that making the outside shell, this is what goes around the very outside, a little bit thicker, adds to the stability of the final piece. It's much more rigid that way. So it's a little bit of extra plastic on the outside of these. So I bumped that up to 1.5. I've come down here, and the top and the bottom thickness, I'm going to set those at 1.5 as well. So top bottom thickness of 1.5, it updates here, and all of that's good. The next little drawer is the infill drawer. I don't remember what these settings are, so I'm going to come back. The infill density I did at 10 with an infill pattern of octet. So I'm going to jump back here, and I'll change that to 10, and the infill pattern is octet. There are a variety of infill patterns. I've found octet to work fairly nicely. This varies depending on the 3D printer. The Delta 3D printers have a bunch of different settings, and like I said, Will has gone through and done a bunch of prints where you can see inside. He's cut them off halfway so you can see what it looks like inside and pick the best style. Anyway, I've found this to be fairly reasonable. There we go. The next thing here as we go down is material. Our printing temperature, we're going to bump it up by 10 degrees Celsius. We're going to go to 220. And our build plate temperature is going to be at 60. So this is something that's unique to the Type A machine that isn't part of the Delta makers, and that is that the plate that you build your piece on actually has heat in it. It gets warm too. It's not as hot as the melting plastic extrusion head of the 3D printer, but it helps to kind of glue your piece down to the table. And so we're gonna leave that at 60 and have that heated. We'll come down to the next category, which is speed. That one's set at 60. We're going to leave it as the default. Next one here is travel. We want to check the box for Z-hop when retracted. That just means that if you're jumping from one thing to another, it will go up and over and not knock through an object. So we want to make sure that we're Z-hopping. So that's set. Cooling we'll leave as default. Support we'll leave at default. Last thing here is the build plate adhesion. The default here is called a brim. I think that's perfectly successful. I left it purposely on this orange model so you can see it. It's this little piece that goes around the outside. It's an extra layer of plastic that helps stick this down on the table while it's 3D printing. It's pretty easy, and you can actually see it. It's already falling off on this one. It's pretty easy to take a little knife and slice that off and get rid of it after the fact. So we'll leave that one on. There are a couple other types. There's a brim, but there's also something called a raft, which is a much thicker build plate. It makes it a little bit more stable. If you're trying to 3D print something that's smaller or more complicated, sometimes increasing that can help. But at the same time, it's harder to get rid of it after. It's harder to cut it off than the brim. So we're going to go ahead and leave that as brim. Once all of those settings are done, we can click the Prepare button right here. When I click the Prepare button, it's going to actually go through and slice up the model and get it ready to print. And so it's now ready to print. It's telling me that this model is going to take 2 hours and 5 minutes to print. If we're being honest, I would multiply that by 1.5 or 2 as to the actual time. So this is going to be somewhere around 3 hours, would be my guess, to print. So that's the challenge with 3D printing. So when we did the unrolled surfaces, right, we unrolled those surfaces, we got the laser cut file, you can walk over to the laser cutter, you can glue it together, and you could probably be done with that whole process before this 3D print finishes. That being said, if you set the 3D print to go, and then you had some other stuff to do, and then you came back 3 hours later, you'd have a really cool little 3D printed model that's very durable. So there are certainly trade-offs for which method you're choosing to use. So once I've done that, I'm going to go ahead and save to file. This button down here, when I click on Save to File, this is going to write the G-code. So it's going to be a .gcode file. And I can go ahead and put that in. This is our spring of 2019. There we go. And I can go ahead and click on Save. And that is then the file that you need to be able to take to the 3D printer. So at this point, it's a matter of walking across the way and hopefully finding a lab tech to help you. That's the best strategy. But if you don't have a lab tech, you could follow this Physical Modeling 6.6, which walks you through on the Type A machines how you go through, how you set the temperature, etc., how you prep the print head so that it's extruding correctly, how you upload the file, etc. And that will walk you through how to actually do the 3D print. So for our purposes today, for exercise 217, I'm looking for two things. One is that unrolled surface screen capture with the red and the blue lines. And the second one is the G-code. You should be able to upload the G-code directly. If for some reason that's not working, I'll go back and double check that it's an allowable file type for you to upload. But I'm pretty sure I set that last semester correctly. So those are the two pieces that I'm looking for today. You will need to do those two things as part of your assignment 203. That will be graded. You need to make sure you have both of those pieces as part of your 203, besides the renderings that we have been working on. Okay? So all of that comes together.